Good morning. Today we will solve exercise 11.2 of chapter 11, that is mensuration. In lecture 1 of this chapter, we have learned the derivation of formulas for finding out the areas of trapezium, rhombus in general quadrilateral. So, in exercise 11.2, we will apply these formulas. So, question number 1 of exercise 11.2 is the shape of the top surface of a table is a trapezium. Find its area if its parallel sides are 1 meter and 1.2 meter and perpendicular distance between them is 0.8 meter. So, let's see the figure. You can see in the figure that the top surface of the table is in the shape of trapezium, where the length of parallel sides is given as 1 meter and 1.2 meter, and the perpendicular distance between two parallel sides is given as 0.8 meter. This is perpendicular distance, that is we are taking as height, and this 1 meter and 1.2 meter, that is the parallel sides length. So, only you have to use the formula and insert the values and find out the area. So, first let's write the information, as we are not writing the question, that area of a trapezium equal to half into sum of parallel sides into height. Now, here already in the figure measurement is given, so we will directly insert the measurements, that is equal to area of the top surface of the table equal to half into parallel sides, you can see here, that is 1.2 plus 1, and into height, and height is given as 0.8. So, we insert these values, that is half into 1.2 plus 1 into 0.8 meter, that is equal to, further solving, half into 1.1 plus 1, that is 2.2 meter into 0.8 meter. Now, here we can cut these two, either you can cut with here 2 ones are and 2 1.1 will get. So, that is equal to 1.1 meter into 0.8 meter, that is equal to 0.88 meter square. Thus, area of the top surface of the table is 0.88 meter square. Now, question number 2. Dear students, please keep your textbook next to you when we are solving the exercises based on mensuration. So, question number 2, the area of a trapezium is 34 centimeter square and the length of one of the parallel sides is 10 centimeter and its height is 4 centimeter. Find the length of the other parallel side. Now, here in this question, already the area of trapezium is given. With that, length of one of the parallel side from the two parallel side is given and the height is also given. We have to find out the length of other parallel side. So, question number 2, let the length of the other side of a trapezium equal to a centimeter. Already it is given, length of one of the parallel side of a trapezium is 10 centimeter and the area of trapezium equal to 34 centimeters square and height of the trapezium equal to 4 centimeter. So, using these measurements, we can find the missing one parallel side length. Now, we write the formula, that is area of a trapezium equal to half into sum of parallel sides into height. Now, already area of trapezium is given as 34 centimeter square equal to half, as it is we will write into. Now, from parallel sides, one of the side is given as 10 centimeter and another we have supposed as a. So, we write 10 plus a centimeter into height given as 4 centimeter. So, we write 4 centimeter. So, we get 34 centimeter square equal to half into 10 plus a centimeter into 4 centimeter. Here you can cut 2 ones are and 2 twos are easily, as everything is in multiplication. So, we will get 34 centimeter square equal to 10 plus a centimeter into 2 centimeter. Again, we will transpose first this 2 on the opposite side. Yes. So when we transpose 2 in the opposite side, as it is in multiplication, it will become division. That is, for the solving we will get equal to 34 upon 2 equal to 10 plus a. Now again we can cut 2 and 34, 2 ones are and 2 17s are. So we will get 17 equal to 10 plus a. Therefore a equal to 17 minus 10, that is 7 centimeter. Thus the length of other side of a other parallel side of a trapezium is 7 centimeter. Next, question number 3. Length of the fence of a trapezium shaped field ABCD is 120 meter. If BC equal to 48 meter, CD equal to 17 meter and AD equal to 40 meter, find the area of this field. Side AB is perpendicular to the parallel side AD and BC. Okay, it's given that one field is in the shape of trapezium and the field is given as ABCD. Now in this field, length of three sides of the field is given. Fourth side length is not given. Also the perimeter of the field is given. Along with it is also given that two sides are parallel, that is AD and BC is parallel, and also AB is perpendicular to BC. This all information are given in the question. So when AB is perpendicular to BC, AB will become the height and BC will become the base. So we will take AB as the height, but here AB length is missing. So first, from the perimeter, we are using the perimeter of the given field, we will find out the missing length of AB. So let's see the figure first. Here you can see ABCD, where length of BC, CD and AD is given and AB is missing. Also AB is perpendicular to BC and AD and BC are parallel sides of the trapezium field. So let's start. That is, in trapezium ABCD, BC equal to 48 meter, CD equal to 78 meter and AD equal to 40 meter. Now length of the fence, that is nothing but the perimeter of the field, that is equal to 120 meter. It is given. We know that the perimeter of a trapezium is nothing but summation of all the four sides of the trapezium. So we will write AB plus BC plus CD plus DA equal to 120 meter. Now already we are knowing the measurement, length of three sides, so we can find the fourth side length. That is AB plus 48 plus 17 plus 40 equal to 120. That is AB plus 105 equal to 120. That is AB equal to 120 minus 105, that is equal to 15 meter. So we got the length of side AB as 15 meter, which is the height of the trapezium. Now let's insert this in the formula. That is, area of a trapezium equal to half into sum of parallel sides into height. That is equal to half into, now parallel sides are given AD and BC, so we'll write AD plus BC, and height is given as AB into AB. Now we insert the values of these three sides, that is equal to half into 40 plus 48 into 15, that is equal to half into 88 into 15. Now here you can cut 2 ones are and 2 44s are 88. Yes, so we will get equal to 44 into 15 meter square, that is equal to 660 meter square. Therefore the area of a trapezium shaped field is 660 meter square. Now next, question number 4. The diagonal of a quadrilateral shaped field is 24 meter and the perpendicular dropped on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area of the field. Now here in this question, only general quadrilateral is given. So we will use the formula of area for general quadrilateral and find out the area. Now what informations are given, let us see. Here you can see the quadrilateral shaped field where two perpendicular height, here you can say distance is given. Here these are the two perpendiculars whose height is given, and the length of the diagonal is also given. So we can use this and then find out the area of the general quadrilateral. So next question number 4 is diagonal of a quadrilateral shaped field is given as 24 meter. We write the information as we are not writing the question. So we write the information so we can calculate it properly and solve the sum properly. Also height of perpendiculars, that is two perpendiculars are given. Let one of the height h1 equal to 8 meter and h2 equal to 13 meter. Area of the quadrilateral equal to half into d into h1 plus h2, where d is the diagonal of the quadrilateral, h1 is the height of one perpendicular and h2 is the height of another perpendicular. Now already we have this all the measurements, so we insert in the formula, that is equal to half into 24 into 8 plus 13 meter square. Now here you can cut 2 ones and 2 12s. So we will get equal to, here if you are not cutting also you can keep as it is, you can cut in the next step. That is 8 plus 13, so we will get half into 24 into 21 meter square. So we will cut here. If you want to cut up also you can cut, but in this step cutting is better. 12, 2 ones and 2 12s. Now we will get equal to 12 into 21 meter square, that is equal to 252 meter square. So the area of a quadrilateral shaped field is 252 meter square. Now question number 5. The diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Find its area. Now very easy this is, because as we know that the formula to find out area of rhombus is half d1 into d2, that is half into a product of diagonals. Already both the diagonals measurement is given, so we can insert and we will find it directly. So solution number 5. Diagonals of the rhombus are d1 equal to 7.5 centimeter and d2 equal to 12 centimeter. Sorry, it is written by mistake too. It is 12 centimeter, dear students. Don't make a mistake. Here it is 12 centimeter. So when you are writing, please write properly. It is 12 centimeter. Further, it is given area of the rhombus equal to half into product of diagonals. That is equal to half into d1 into d2, that is equal to half into 7.5 centimeter into 12 centimeter. Here you can cut 2 ones and 2 6, and then we multiply both the numbers, that is 7.5 into 6, that is equal to 7.5 into 6 centimeter square, that is equal to 45 centimeter square. So the area of rhombus is, thus the area of the rhombus is 45 centimeter square. Question number 6. Find the area of rhombus whose side is 6 centimeter and whose altitude is 4 centimeter. Altitude is nothing but height. If one of its diagonal is 8 centimeter long, find the length of the other diagonal. Now here first rhombus side and height is given. Also one of the diagonal is given and we have to find out the length of the other diagonal. So for solution of question number 6, side of the rhombus is given as 6 centimeter. Altitude, that is height of the rhombus, is given as 4 centimeter. Length of the diagonal, that is one of the diagonal length, is given d1 equal to 8 centimeter. Now we know that a rhombus is a parallelogram. Rhombus is one type of parallelogram only. So we use the formula for area of a rhombus of a parallelogram to find out area of rhombus first, because its height and base both are given. In rhombus all the sides are equal, so you can take altitude with any of the sides. So area of rhombus equal to base into height. Now here you can see base, that is already given, side of the rhombus as 6 centimeter, and altitude, that is nothing but height, so we'll take height as 4 centimeter. That is equal to 6 centimeter into 4 centimeter, that is equal to 24 centimeter square. Therefore the area of the given rhombus is 24 centimeter square. So now using this area and one of the diagonal length which is given, we will find the length of the other diagonal. Now we know that area of, and we suppose that let the other diagonal of the rhombus equal to d2. Now the area of the rhombus equal to half into d1 into d2. Already we have found out the area of rhombus in above step, that is 24 centimeter square. So we will write 24 centimeter square equal to half into 8 into d2, because d1 diagonal 1 is given as 8 centimeter. So we can cut here directly, 2 1s are into 4s are, and then we will transpose 4 on opposite side. So we will get equal 24 equal to 4 into d2. Now we transpose 4 on the opposite side, here this will be transpose here, so multiplication becomes division. So 24 upon 4 d2 equal to 24 upon 4, yeah, 24 divided by 4. Now we know that 4 6 are 24, so we'll write 4 1s are and 4 6 are. So d2 equal to 6 centimeter. Thus the length of the other diagonal is 6 centimeter. Dear students, please copy all these solutions of 6 questions of exercise 11.2 in regular CW with figures in whichever question it is given. We will continue and solve the remaining questions of this exercise in next lecture. Thank you.